This is my solution for the lesson 101 homework for Paul McWhorter's Pico W series, where we took our servo class out of our application program and moved it into a library. So we'll first look at that class. It was the class out of the program that I had in my lesson 100 solution, which was a little wrong, but I improved it after watching the Paul's 101 video. I moved the state machine frequency value up into a variable, going to be a class variable. The period for the servo, the slope and y-intercept for the line, equation of the line that converts an angle in degrees to a pulse width in microseconds, specific to the servos that came in the kit, the SG90s. You'll notice the class method I added was down in the other methods before, but it really doesn't depend on the objects. So I moved it up into the class and learned about this decorator you can put. The SMNum variable keeps track of which state machine we're using. We'll start at 0, that's the next available state machine, and as we add servo objects, we'll increment this value. So each servo object will use a different state machine. Here we have the PIO code that would be used for a state machine, all state machines. And that ends the class definitions. Now we get down to the object code definitions. We have our constructor, the init method, dunder init dunder. We save the pin value which the application program provides, and then we declare our state machine. We use that class variable SMNum, which is set to the next state machine number, 0 in our case right now. We use the PIO program, which is above, the frequency, which is above, in a class variable, and the application passed in value pin. I increment that state machine number so that any future servo creations will use an available number. The current one is marked as active. Servo state machine is not active. We initialize the state machine ISR and OSR. ISR to the period. That's done in these 3 lines. And then we take an initial angle of 0 and put it in the OSR and copy it to the X register. That's because of the pull no block that's in the PIO code above. Move on down. An application program will call set angle to set an angle for the servo. In that angle, if the servo is running, so if the state machine is active, that angle is at least sanity checked to be between 0 and 180, converted to a pulse width using that class function, class method, and then put to the servo for the object. A user or application would start their servo by invoking the start method. So if the servo in being activated is not yet active, it'll be marked active, and that flag will be set to true now. just the opposite for stopping it. The user will call to have it stopped. If it is active, the state machine is stopped and the flag is set to false. This last one's just something to do like a Java 2-string, prints a simple version of what the servo is. This servo.py file is up on my Raspberry Pi, but it needs to be down on the picow. So let me go to View, Files. That was already there. Down on the picow, I already have a servo.py. And it's the same thing that we're looking at up on the host. Now let me come over to the program. Program's pretty simple. You have to import that servo class. And remember, this will be done down on the picow. I need time at the end of the program. You'll see why. Program creates the two servos. I used GPIO pins 20 and 21, then starts the two servos, and then enters the loop to sweep them. I've changed from doing it forever to just doing it 3 times. It's the same code as before. Go from 0 to 180, and then go from 180 back to 0. Intentionally duplicating 180 and duplicating 0. And you'll notice now all the user has to do is just set angle. None of that state machine code is here. So after those 3, I stopped the servos. And before I added this time sleep, I noticed that the second servo arm remained at 180 degrees, even though I'd said move it. So I added a stop time of 1/10 of a second and ran it, and it only moved to 45 degrees. So I upped it to 2/10 of a second. Now they both stop and move back. So let's run it real quick. Watch the servos. There they go. There's one. Almost done. Done. And notice that that second servo over here did get back to 0 degrees. Okay, that's the end. Thanks for watching.